Duda. Good? Good morning. I'm glad everybody could make it out today in this nice weather. I only really got one thing. I am going to step down from being the president. I really haven't did much. Really, it's been Jason and Brandy and Dave doing most all of it. But I would like to put it out for anybody who wants to be an officer. I'd like to nominate Jason as president. So if I could get a motion or second and an aye or whatever. So everybody agreeable to that? Aye. Okay. But now we need a vice president. I'd like to nominate Brandy, but she don't really want it. So, and she's done it a lot longer than I have. So we're looking for anybody. Wow. Come on. High pay. Pays a lot. So, really, that's all I have. So I'm going to turn it over to Hunter and go from there.
Good morning, everyone. My name is Hunter Hardesty. I'm with Gas Voting Associates. I've been with them a little over 9 years now. Am I good right here? Better. Sorry about that. This morning, I've got two presenters for you. We've got Jun Tao from EcoFix and Alan Smith from BioGill, who's off camera. Both of them specialize in biological treatment in two different ways. One focuses more on lagoons and municipalities. One focuses more on industrial facilities, lowering BOD, COD, pH, and those kind of things. Without further ado, I'll bring up Jun Tao, our first speaker with EcoFix, let him introduce himself, and let him give his presentation. Thank you.
All right. Can you hear me okay? All right, thank you, Hunter. So my name is Jun Tao. I'm a business development director at EcoFix. So we are based in Canada. Really happy to be here. Thanks a lot for having us. Like I was telling Hunter, feeling a bit overdressed. Probably should have not worn a blazer, but it's okay. I guess it's okay to stand out. So we're specialized in biological wastewater treatment, and what I want to talk about today is how to help. You can go to the next one, or maybe I have yeah. Okay. So what I want to talk about today is how to help small and rural communities when it comes to their wastewater treatment plants, and more specifically, how to help them upgrade their plants to meet with higher capacity needs or changing regulatory compliances, and while giving a second life to their existing installation. So when it comes to small and rural municipality, one of the most common way of treating wastewater is a lagoon system. It's very simple, it's cost-effective, low maintenance as well. I think there are over 10,000 lagoon systems across the US, over 3,500 in Canada as well, actually. And when it comes to upgrading those plants, some of the conventional methods of doing so, such as a conversion to a mechanical plant, a MBBR, or another system that would replace the lagoon process, will have some pretty unique challenges for those municipalities. So first of all, the lack of resources is a big one, right? It takes a lot of capital cost to do those upgrades, the lack of human resources as well. Often when you go with a more complex process, it takes more qualified operators to do so. The lack of space could be a big factor. Adding footprint will, remove from green areas around the wastewater treatment plant and could have, ecological community impact in that way. And most importantly, I believe, is the lack of flexibility. When you make permanent infrastructure changes to what you already have, you have very little flexibility. You pretty much have to design your upgrade for the next 20 to 30 years whereas there are other alternatives that can allow you to give a second life to your existing plant that could provide you with more flexibility. So you can see a few examples of what I'm talking about here on the screen. So the approach that I want to talk about is to basically submerge modular fixed bed into an existing lagoon or an existing bioreactor to enhance and intensify the existing treatment. So, all right. And like I said, not only lagoons, other type of bioreactor as well could be a good fit for this. You can see the first picture up there is a concrete tank. So there's different versions of this type of solution that's available for different type of bioreactors. But yes, lagoons are a great fit as well. And the city of Ascot Corner is a good example of what we discussed thus far. So this is a municipality in Canada. They operate a aerated lagoon with 2 cells. It's a small municipality, 3,500. It's a pretty typical situation from where I'm from. And the issue is that they needed to increase their BOD treatment capacity by 40% to accommodate their growth, so 300 additional homes. So for the city of Ascot Corner, what they decided to go with is a modular fixed growth system, like the one you see on screen here. So I'm going to play a little animation. So this module in particular is called the EcoFix module. It has an external structure made with stainless steel. The white section in the middle is the fixed bed media, which I have a piece of it right here. And there's also an integrated aeration system at the bottom of each module to feed it with air, but to clean it as well. So, yeah, sure, go ahead. And the module itself is really simple. There's no mechanical parts on it. It's all stainless steel and plastic, so it's easy to maintain. And it was designed this way because it was designed for small and rural communities. Yep. So this type of solution can be used to treat different contaminants. In this case, we're going to take a look at the BOD removal with the EcoFix module, as well as cold water ammonia removal with the BioFix module. So both can be combined within the same installation if needed to treat both BOD and ammonia. And how it works is really simple. You probably guessed it already. These are going to be submerged into an existing bioreactor to provide the biomass with a surface to colonize. So that's going to help the bioreactor maintain more biomass and treat more loads of BOD and ammonia, while at the same time optimizing the existing aeration as well, or to add aeration if there is none. So you see an example for an aerated lagoon here, where the modules are going to be submerged in between the existing aeration lines and then anchored with steel cables to the shore. So they're basically FBBR or IFAS solutions that come in a modular form that's been adapted to help small and rural communities. As I mentioned before, there are different versions of this type of module. The anchored version can go into a SBR, activated sludge, with the same principles, whereas the floating version, it was designed for lagoons. So the choice of media material was very important for the city of Ascot Corner. So fixed bed media is nothing new. It has been around for a while. It's a proven technology, but the design of the media was often a weakness. So often you will be a strain or rope-like material, just like the ones you see here, on which you will be great for biomass colonization, but it will create a lot of clogging as well. So clogging will create anaerobic zone, will make wastewater bypass the treatment, create short-circuiting, for example. So that would require regular maintenance, and it's also material that could break over time, so they will require replacement as well. So what we did with the EcoFix and BioFix media to address those concerns, I'm not sure what that piece of media is currently, is that we made it in a three-dimensional structure. So it's a shape of a cylinder that has a lot of surface area for biomass to grow, but also plenty of space in the middle to avoid clogging. So that piece of media is installed vertically inside of the module so that the aeration can hit it at the right angle to clean it. It's also a rigid structure made with a thick plastic, so it's not going to degrade over time, and you won't need replacement. Now, when it comes to the integrated aeration system, it's used for a lot of different reasons. First of all, it's going to push air and oxygen into the media and the biomass to feed it, but also it's going to create an action zone. So that's what you see illustrated in red right here, basically increasing the surface area of the treatment to avoid short-circuiting and make sure that the entire flow of the wastewater is covered. Maintenance is also done directly through the aeration system. So the modules will remain inside of the bioreactor. You don't need to remove them. And you simply need to adjust the aeration every 4 to 6 weeks to basically blast it with air and clean it, remove any debris. Ascot Corner, yeah. So you can see the installation for Ascot Corner right here. So 3 modules submerged inside of the first lagoon. You can see that the line of module is perpendicular to the direction of the wastewater. We position it that way to maximize the contact with the wastewater, and that combined with the action zone will help treat the entire flow. Then the modules are connected to those concrete blocks with steel cables to keep them in place. And right here, you can see the manifold. So this is where the connection to the air of the blowers will be, and also where the valves to adjust aeration for maintenance will be as well. In this case, Ascot Corner had existing blower systems and existing aeration system that had enough residual capacity. So the modules were simply connected to the existing aeration line. You can see that an engineer compared the cost of the EcoFix fixed growth module with a few standard MBBR solutions, and it came out pretty favorably for the fixed growth module, both on the capital cost and on the O&M cost as well. All right. So for Ascot Corner, the economic advantages were pretty obvious. They were allowed to give a second life to their existing lagoon rather than add infrastructure or change it to a more complex process. So they save a lot of money in terms of the capital expenses and also in terms of the recurrent O&M cost. Flexibility is a big factor as well. So if we just go back here, you can see that the lagoon still has plenty of space to add more modules if they want. So not only it will help them with their current objectives, but in the future, they can still add more modules in the lagoon and even add biofix module in the second lagoon if they ever have a more restrictive ammonia limit. So that's a level of flexibility that you have to deal with the changing regulatory landscape and your growth as well. So here you can see the assembly of Yeah, it is really simple, and that's the goal, is to make it easy to operate and to maintain. And those block of media are made with those cylinder shape that you saw, that are fused together with heat and then inserted into, thank you, Alan, into the stainless steel structure. Assembly and installation is a big plus as well, because that can be done pretty quickly, usually within a week or so, and without having to disturb any of the ongoing operation. Also, it is shipped in pieces and assembled on site, so if it is in a rural area, it will be easier to reach as well. You can see the module submerged here, as well as the aeration happening around it. And of course, by enhancing biological treatment, we're avoiding the use of chemicals, consumables, very energy efficient as well, by optimizing aeration, but also by allowing the bioreactor to maintain more biomass and treat more loads of contaminant per kilowatt of energy consumed.
As you can see, there's not an issue here. So, we've been freezing weather the past couple of weeks here. This will continue to work. It's working in Canada, obviously. So, freezing is not a factor.
Yeah. Thank you, Hunter. So another important factor is that most of the material can be built locally. So the media, obviously, is the proprietary part. It's going to be built in Canada, but the stainless steel can be built locally. And that's the majority of the equipment cost, is the stainless steel. So any BABA requirements, so this type of solution can easily comply with. Now, when it comes to performance, because that's the most important part, right? It can be easy to maintain, it could be simple, but does it perform? So you can see here of what the actually increase in BOD loading was. So a 40% increase was expected, However, Ascot Corner, just like many municipalities, had some unforeseen circumstances where another wastewater treatment plant, which was a biodisc plant, had a mechanical failure. So they did transport the wastewater into the lagoon, which actually increased the organic loading by 70%. And you can see in green is the evolution of the flow, and in blue, the organic load. Those light green and blue lines that are straight, those are the design parameters. And you can see that they are, obviously way over in both cases. Now, the good news is that the same 3 modules that was submerged into the lagoon was still able to handle the additional load and treat their BOD level at the effluent below their limits consistently. So that's 20 milligram per liter in summer and 25 in winter. So essentially, Ascot Corner was able to, simply by submerging those modules, increase their treatment capacity by 70% and really reach their long-term goals without having to change their existing lagoon process and without having to add any infrastructure. Now, TSS could be a concern as well, but the good thing is that although the EcoFix module was not designed for TSS removal, it does have a positive impact on its final results. And that's because having additional biomass in the bioreactor will create a buckling effect. So the biomass will attach themselves to the suspended solid and help them settle down more efficiently. So that improves the final results in that regard as well. So here is what's called a life cycle assessment. So this is done by a third party to kind of compare the impact on greenhouse gas emission of the different alternatives that were studied. In this case, the third party found that the EcoFix system will emit 80% less greenhouse gas than a MBBR over its lifetime, so from production to the end of life, while considering infrastructure, energy consumption, and etc. So it is a significant impact. So that's the equivalent of 5 less cars on the road per year for every 100 cubic meter per day of wastewater treated. And not only this type of study helps quantify the impact on the environment, Ascot Corner was also able to get a very nice green technology fund from the government of Canada to fund a good portion of their project. Now, ammonia removal could be a big issue as well, especially in lagoons in cold climate communities, just like in Canada, just like here. Here we have an example for the city of Drummondville, and you can see before they did anything to their lagoons, ammonia removal was quite a big issue as their effluent limit was below the 5 milligram per liter regulation for only a couple of months during the year. So a lot of work to be done here. And now after the BioFix module was installed inside of the lagoon, after a quick ramp-up period, the effluent was lowered to below 1 milligram per liter consistently. And that's even during the coldest month of winter here, December, January, February. It gets pretty cold. Minus 20 Celsius, minus 30 Celsius is pretty common in that area. Not sure what that is in Fahrenheit, but it's cold, trust me. Yeah. So the BioFix, you can expect a removal rate of 98% or more of the ammonia load that's going to be attributed to the module and can really allow the lagoon to maintain effluent limits below their limits year-round without heating the water. I should probably explain how that's done. So one of the things we did with the BioFix is that we apply a coating of biogel on the media. So that's something that was developed with research centers in Canada. And that coating of biogel will protect the nitrifying biomass, but also increase the surface area for them to colonize. So this is kind of the way that we're able to maintain biomass in cold water. You can see the comparison here, as well as more information on the actual outflow and inflow concentration for ammonia. And here you can see that temperature samples was taken inside and outside, well, at the entry and at the exit of the module, just to indicate that no heating of the water was required to reach those results. So that's pretty much towards the end of my presentations. Thank you for your time. Any other questions?
Yeah, questions, comments, any thoughts on anything? Extra air do you need to leak it?
So the question was, how much extra air do we need to clean the media? So sorry, but I'm not an engineer, so I don't have the numbers in hand, but I do know that there is a constant level of operation for the module, and then there's a max level of aeration that will be used to clean the module. And actually, it's not going to be extra air from the blower. If we go back a couple of slides, well, more than a couple of slides. For example, here you have 3 modules, right? They are fed by the same blower on the same aeration system. What happens during cleaning or during maintenance is that the operator is going to close 2 of those modules. And then the extra air is going to go to that one module with aeration on. That's going to clean it. And then the adjustment will be done again for the 2 other modules. So it's kind of like a adjust and put a timer, go do something else, and then come back to it. So that's why the maintenance is pretty simple, because again, the modules stay inside of the lagoon. You don't need to remove them.
So all you're doing is reallocating which way you want air.
Yeah.
So they ain't gonna take the air away from your operation? So are you going to upsize your blowers?
I don't believe so, unless you had a larger capacity population, like that, maybe. My assumption, but we can always look into it if need be.
It is a case-by-case analysis. In that case, it depends on what you already have, what you're trying to treat, and what your objective is. So it'll be hard to. Yes, sir.
Now, normal operation is there constantly, right?
Yes.
Off, on, alternating.
Constantly, yes. And it's possible to adjust it as well, depending on the season, right? Sometimes during spring, there's more pressure on the system. You're going to put more air. Maybe during summer, you can lower it. So that's all part of the operation and maintenance optimization to keep energy consumption low. Yeah. Yeah, absolutely. So, all right, let's go back again. So you see right here, this is the manifold. So this is where the valves will be. And then these will be connected to blowers. Yeah, there's 3 flexible hoses to feed the 3 units. They're connected to the same manifold, and then that manifold is connected to the blower. So blowers could be provided as well as part of the package. And also, if utility building or space is an issue, adding a small weatherproof cabinet to house the blowers could also be an option, as long as there's electricity on site. Yes, sir. Good question. No, not yet. Soon. We're working on it. So there are a lot of installations in Canada where there's the climate is really cold, so we have a lot of performance data from those for comparable situations in Illinois, and so the first installation in Illinois is still in the works. That's a good question. So with any biological treatment process, removing the sludge before doing the installation is always a good idea. So that's not an exception for this type of solution. It will help, but it's going to depend on the sludge level. If it's still reasonable, then it wouldn't be an issue. And the good thing with the floating module is that you have plenty of clearance between the bottom of the lagoon and your module. So if you're going in with a drag to remove the sludge, you don't necessarily need to remove the module from the lagoon. You can go under, or you can disconnect one of those cables, kind of move them around, and then clean the sludge that way. We usually consider 15%, 20%. Over that, like a removal is probably due. So I'm not sure in Illinois what is the frequency, but in Canada we usually do it every 2 years, 3 years, to keep it at a consistent level. But again, that's something that
You too, right?
Almost sounds like this would be the answer to global warming.
I wouldn't go that far, but it is a good start.
So, is this designed specifically for lagoons, or if your plant is having problems with ammonia discharging, could you put that possibly as a flow through on the tail end of the plant?
Absolutely, yes. So the floating version is designed for lagoon, but that can be adapted. So there's the anchored version that can go into a concrete tank, and it's also possible to kind of customize it, right? It's basically media aeration that's inside of those modules. So you can size it to the way you want and put it inside of a precast tank or something like that. Like we are working on a project right now in Illinois where it's a sand filter, recirculation kind of situation where we're adding a additional tank at the end to treat ammonia that has our components inside. So it's, it can be adapted to your situation. Right here.
That right there is,
That's an example. Yeah.
one you can see they're actually put in different locations in one kind of same space.
And one thing I should probably mention is that although retrofits are most of our focuses, you can also include those in a new plant, right? By including that in your design, you can resize your plant, make it a lot smaller. And what we've seen thus far is up to 4 to 5 times smaller in terms of the required footprint of a new plant by including the media or the module to optimize the biomass retention. Other questions? Yep. Yeah, 4 degrees Celsius, I think, from... yeah, so let's take a look at those. So you can see the average winter inflow temperature, 1.3 degrees Celsius, 3.3 degrees Celsius. So yes, you will work below 4 degrees Celsius. And up to 0 degrees Celsius, as long as the water doesn't freeze. So these were taken at the entry and exit of the biofix module. Other questions? Okay, sure. All right, well, thank you for your time. Appreciate it.
Thank you, everybody. We're going to take a little break here before Alan comes up on stage and gives his presentation. So we will see you shortly. Thank you. All right, guys, we're back here again. We've got Alan Smith here coming up next with BioGill. Alan's got quite the track record, long history of sales, health and safety, consulting. I'll let him kind of introduce himself and give his spiel. So without further ado, Mr. Allen.
How you doing? Okay, so hold that for a second. You gotta clip this on, I guess. Yes, sir. First of all, what a cool product EcoFix is, right? That's a very impressive product. I am Alan Smith. First thing I'd like to tell you is that I'm from North Carolina. And you people, I don't know, y'all are a hardy group. When I got off that plane Tuesday, and it was -3 at a wind chill of -25, I just about got back on that plane. I'm very impressed with your ability to withstand cold. BioGill, I'm the sales manager for the eastern half of North America and the Caribbean. And BioGill is a relatively new company. It is in the simplest terms, a trickle filter. But they created a very special item that they call the gill, which makes it an unbelievably efficient, in a very small space, way to remove BOD, with the added benefit of being incredibly environmentally friendly. It has an extremely small carbon footprint. And to a lot of people, that's very important. Some it's not. But a low carbon footprint also means very low operational costs, because the energy bills associated with it are minuscule compared to most other products out there. So we're going to introduce you to it. I know this is kind of supposed to be non-proprietary, but as of right now, BioGill is the only company with this technology, so it's kind of hard to do that. But the company was founded in Australia by a couple of scientists with a government grant. And they created this medium. It's a nanoceramic material. And somehow the scientists were able to get the patent for it from the government. And they created BioGill. It's a very robust, very low energy cost, very efficient removal of BOD, COD, TSS. So the company in 2005 was when the government grant for the technology. We have won many, 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 many awards for the uniqueness and the greatness of this product and how it works, including the Best Challenger Award, Innovators Award from the Ministry of Science and Technology in China, Top 10 Innovators, and Imagine H2O. The company in 2021 was purchased by a very large European company called BW Water, which builds municipality water treatment plants. And at that time, the stuff began to change. They recently took over for North America this year. We are all over the world, as you can see, with installations quite literally everywhere. And depending on where you are in the world, kind of depends on what we do. In the United States and Canada, we have mostly been food and beverage, although we're starting to do a lot of work with municipalities. In Brazil, 100% of our jobs are prisons, hospitals, schools. In China, it's almost all small communities and municipalities. So we're a very varied or very flexible product. A little hoarse from the cold weather, sorry. All right, so it's a very simple design. And by the way, that is an older picture. Our company is doing new marketing. They haven't delivered our new PowerPoints yet. It's all stainless steel and metal now. But you have your inlet wastewater is pumped to the top of the reactor from a recirculation tank. We have something called the HydroSwirl, which we're real proud of. It's a non-clogged manifold that evenly distributes the water across the top of the growth media. And then we have our gills, and we'll talk more about the gills because that's what makes us extremely unique. But the microbes grow on both sides of the semi-permeable gills. And so we have at the same time both water, anaerobic, and aerobic sides. And our anaerobic side still gets oxygen, so we don't have a smell. If you were to open up one of these guys and take a whiff, it'd smell like a shovel full of dirt. So it's a very, very, very low odor.
Yeah, so what's happening inside that gill is creating the perfect storm for wastewater. It's having aerobic on one side and anaerobic on another. And it passes through those gills approximately 40 to 46 times before it leaves the biofilm. The amount of BOD reduction, COD reduction.
Massive. Yeah, and that's considered a cartridge. In that one cartridge, we got 2,400 square feet of growth space because of the nano. And we also, like John Tu's product, we have a biogel to make the ours actually tastes better on toast. Sorry, but but we have a similar thing. There you go. The air vents, and here's another great thing about us. Yes. Oh. Oh. Okay. All right. So then we have the air vents here that are drawing in air from the bottom and bringing it to the top. One of the reasons we don't have such a small carbon footprint is we don't require any blowers or aeration. Because we have a dry side that's always dry, this natural convection provides all the oxygen we need for our microbes. No blowers, no aerators, nothing like that. As a matter of fact, on our very largest unit, the only thing electrical is the control panel and 2 1.5 horsepower pumps. And then the outlet is the treated water going to discharge. So this is kind of our gill, or the science of our gill. We have an air side and the water side. The oxygen transfer occurs directly from the atmosphere to the air side of the biomass. So we got oxygen coming up from the bottom to the air side. No water boundary layer to impede oxygen mass transfer. The gills work sort of like fish gills, why we call them gills. On the dry side, the gills allow oxygen to go through to the wet side to provide oxygen to the bugs on the wet side. The wet side lets the nutrients go through to the dry side, feeding the bugs and removing BOD. We're really good in fog because of that, fat, salts, and greases, because it's very difficult to remove fog in a submerged environment. Because our dry side is dry, we get good contact with the fat, salts, and greases suspended when they pass through the gill layer. So we're very good at that type of removal. The air side biomass is separated from the solids, like I said, and the energy or the food goes back and forth. The water side biomass can experience anoxic, anaerobic, or aerobic conditions depending on the nutrient loading. The nutrients are applied from the wastewater to the water side biomass. The nutrients diffuse from the water to the air side. And it's a very unique system, and it's very, very efficient. This is go ahead. That's a SEM image of our gill. It has all these nooks and crannies, like an English muffin. Gives a tremendous amount of space for our growth, our bugs to grow upon. And again, in a cartridge, you're going to have about 16 of these loop gills. A cartridge is about 4 foot by 4 foot by 7 foot. Very small footprint. And here's a look at a kind of a cartridge opened up in the loop gills. You see over here the lighter brown is the aerobic biomass, and the darker is the anaerobic biomass. The counter diffusion as oxygen and nutrients come from opposite sides of the gills is what creates our great efficiency and keeps our odor down. And our sludge yield is very low. Our sludge yield for high strength, 4,000 BOD or higher, is about 0.2%, 0.2 to 0.3%. And it's good sludge, it's bugs. So here's how we kind of fit in. Side streaming a high strength water if you need it. After you do your screening or solid removal and your chemical balancing of pH, we're going to be right there. And then you do your sludge management and your discharge. And as long as it can be eaten, right, we can remove it. If you're getting into metals and things like that, we're not going to do anything. We're going to be strictly, and there are some chemicals that won't work with us, but they're very few. We're actually doing a project for a company that has a low amount of cyanide, but the cyanide aerates when the hydroswirl is spreading the water over the gills, and it's not enough to kill our mass. If you do something bad and shock the system very badly, a tanker truck of Clorox dumps into it, and you kill all the bugs, you simply hose them off. And by the way, that's the maintenance on this unit. The maintenance on the biogills is very low. It doesn't require a level 1 or level 2 operator. It doesn't require a licensed operator at all. We have these things in breweries where the local bartender's the biogill guy. Typically, all you want to know is, are the pumps running? And then every 2 to 3 weeks, depending on your nutrient loading, you literally open a hatch and hose off the extra life. Hey, you see the game last night? Yeah, okay, cool, pretty good, right? You just stand there, wet a water hose, and hose off the extra biomass. That's the maintenance on it. An hour, if for a unit, our biggest unit, the Ultra, you're looking at an hour every 2 or 3 weeks, hosing it off, and then checking it daily to make sure the pumps are running and all your connections are good. We estimate, I'm going to show you some OpEx cost comparisons and electrical usage comparisons. In it, we put in 8 hours for 2 Ultras, which is 20 cartridges a week, but it's nowhere near that much. We just did it to try to make it look more reasonable. Some of the great features, very simple to install and operate. A unit has 3 pipe connections and 1 110 volt connection. We can also do 24 volts for the control panel. Very easy to maintain, as I just told you about. It's very modular and scalable. We have lots of systems where we go in and we put in 4 cartridges, and the company's planning on expanding or doubling their capacity in 5 years. They don't have to do anything else. They just add more cartridges, right? As their volume goes up, they add more cartridges. And it works. We do a lot of stuff, too, with we're starting to do a lot of stuff in North America with municipalities. One of the first orders GasVoda got, a little small community in Wisconsin. Life was good, everything was fine, and a microbrewery came in. And the microbrewery completely overloaded the city's wastewater treatment plant. So the city contacted us, and we put in our system at the brewery in order to keep to fix the problems they're having with the municipality. In Beaufort, South Carolina, there's a little island a company got. It's all, I don't know if you know that area, it's all marsh and wasteland and all. Well, there's a company's going to build 2 high-rise condos. The municipality said they couldn't it was just too difficult. To pipe the water back to the system was going to be a real pain. The EPA said that they could discharge into the marsh if they were 25 BOD or less. So the municipality's buying bioreactors from us. They're going to install them in the basement of the 2 high-rise condos and then bill the high-rise condo owners, and we'll clean the water down to 25 BOD and discharge into the marsh. So there's a lot of creative opportunities with. Again, we're going anaerobic treatment in the same pass, very effective and a rapid treatment of high-strength BOD. Boost performance of existing plants, resistant to shock loads. If you do shock, as I said before, and kill all the bugs, you hose them off. In 5 or 6 days, nature will rebug it. We'll put all the microbes back in there. Or you can get a bucket of microbes and dump in the top, right? It's also fine if you isolate it. If you're in a system that you're not using all the time, you can cut off your influent water, cut off your excluent water, just let the water recirculate, and every 2 to 3 weeks, pour a cup of molasses on the top, right? That'll keep the bugs alive. Resistant to it's very low energy and operating costs, which I'm going to show you in a second. Very low order and very compact on-site treatment. The numbers are pretty impressive, but we offer it in a single cartridge. You can see there. Then we have Max 2, which is 2 cartridges. Max 4 is 4 cartridges. Max 6 is 6 cartridges. And an Ultra is 10 cartridges. And then you can stack those up and add them up. We're working on a project with one of his contemporaries at GasVoda for a plant that's going to be does 150, 60,000 gallons of water a day. And it's 15 units, right? So very, very scalable. From a small brewery or a mobile home park with 30 units up to 190,000, 200,000 gallons a day. We can scale up.
Very similar to John Tao's product, this is something you can put in existing system to help lower BOD, COD significantly. So if you have anything
Yes.
coming into town, your pre-treatment coordinator can say, hey, I need you guys to put this bioday unit before you discharge to us. It's a very simple fix.
So we're looking at, yeah, he's correct. And we're looking at around 18,000 gallons, 5,000, 18,000 gallons a day, depending on the strength of the water for our largest unit, which is the Ultra there.
Any more questions?
Yeah, go. We're good with ammonia. We nitrification. The bugs turn it inside their bodies into a form of nitrogen, and then when they die, it's released back into the atmosphere as nitrogen. we would need to know your inlet ammonia and your goal for the outlet ammonia, and we can give you a prediction. All these, although it looks like an off-the-shelf product, we do engineer all this and build to order. So it's not literally an on-the-shelf product. But ammonia is not, unless it's just ridiculously high, right? Then we would want you to do other treatments. But human waste ammonia, things like that. We do a lot of meat processing plants, pig farms where there's a lot of ammonia there. We don't have issues with it. Great question. Here's the hydro swirl. Yes, sir. Oh, yeah. Pardon me?
What's the control panel?
So the control panel on the smaller units is the pump on, is the pump off. On like the Ultra, it controls your pH balancer. It gives you readings from your sampling meter. It controls the pumps. And then it has 3 auxiliary inputs in case you want to put a flow meter in or some other type of thing. So we got the 2 pumps in the recirculation tank. But you may have a pump upstream pumping to your EQ tank. Like I said, it'll control your pH balancer. You may be pumping the effluent somewhere to get it to a sewer drain or whatever. So we can control 3 other inputs. Your pH balancer, we could control 2 on-off valves. On the bigger units, it's necessary. On the smaller units, it's just on-off for the pump. And our smallest unit uses a 0.5 horsepower pump. But that smallest unit could still do 5,000 to 2,500 gallons a day, right, with a 0.5 horsepower pump. So this is how we spread the water evenly over the gills. No, we have never had one of these clog in the field.
Yes, that's a patented hydro swirl device. Like you said, to this day, they have not had one clog at all. Very impressive.
And it uses water pressures, no electrical draw here either. And because of the low electrical draw too, we found, like in China, we do a lot of stuff in China with very rural communities that never had any type of wastewater. And the China Health, whatever division of the Chinese government that deals with health, is trying to fix that. So we could put these in a small community with 20 units. We could pipe all their human sewage to the BioGo unit, and we can run it with a solar panel and a battery. So for those communities that don't have electricity, right? Same thing if there's some parks, national parks, where we can do national parks that were built in the 30s, 40s, and 50s, don't have good sanitation, right? So we could go into national parks and where they have the public toilets, clean the water before they discharge it back into the river down to a reasonable limit, right? Instead of putting raw human waste. There's a number of national parks, people don't realize this, that have the rainwater shower and toilet. And when you flush that toilet, it's going right into the park's water system, because that's just how they did it in the 30s, right? So that's becoming a good little area for us. This shows a tower. This is our single unit. Again, in a sewage waste, up to 13,200 gallons a day. You can see the size of this guy, 88 inches high, 45 inches wide, 45 inches long. If you're in a brewery or winery or a high-strength water, 4,000 or higher BOD, we can still handle 3,200 gallons a day. And we can handle very high-strength water. We have applications like distilleries, very high-strength water. We have distilleries at 16,000 BOD. We have no problem handling that. Takes a little longer and a little bigger unit, but we're able to get their BOD, we're able to get their discharges well below 200. And again, we have the different max series, max 2, max 4, max 6. The bottom tank is the recirculation tanks.
You see the modularity in these as well. So if you had to add, or if you had to take one away, if you had a side stream application that lost a user or something like that, taking the modular unit away or adding a new modular unit.
One I mentioned earlier that we're working with Gas Vote on, they'll have 3, instead of having a tank under each unit, they'll have 3 cast-in-place tanks per 5 units, which would be a great cost savings. We have a company called Gen Foods. They make food. They do all kinds of fruit processing. They private label a whole bunch of jams and jellies. They're 120,000 gallons a day, right? They're putting in 12 of our Ultras with a giant precast. And the savings to them from their surcharges but their electrical bills compared to everything else they looked at was in the neighborhood of 180, 200,000 a year just in electrical bill savings. But I won't go into great detail for each one. But like the Max 4 here, in a high strength 4,000 BOD, we can still handle close to 8,000 gallons a day. In a sewage application, this little guy, 6 feet high, 7 foot long, or 8 foot long, 7 foot wide, up to 26,000 gallons a day. Perfect for a trailer park, mobile home park, an addition, a small community addition. If you don't have the capacity in a small town and then the developer wants to bring in 50 new homes. In the Max 6, in human sewage, we're looking up to 45,000 gallons a day in an 11 foot by 7 foot by 7 foot footprint. And in high strength water, up to 11,000 gallons a day. And then this is our Big Daddy, the Ultra. It's our largest reactor. It's 10 towers. It's still compact in size. It's 2-stage. We're running the water over 5 units, cleaning it, then running over the other 5, the reduced BOD water, to get our effluent. And we have complete system control with pumps, automatic feed flow monitoring and controls, automatic sludge discharge, temperature monitoring. It's basically a sewage plant in a box.
It does have a pH adjustment system as well.
Yeah.
So if you didn't have a pH issue, this does have a
I don't know.
restricting system to keep the pH in balance.
Excuse me. Yeah, and this guy, 1 unit, depending on the variables, but we could get up to 95,000 gallons a day in sewage and up to 15,900 gallons a day in a high strength water. It's pretty impressive. We have a number of markets: sewage, aquatic, maritime, aquaculture. Food and beverage has been primarily what we've done in North America so far. And I have some, I'm not going to go through these. I want to go through the, so can you, where'd Mark go? Is that Mark? Oh, he was going to switch it over to the PDF for me.
He can hear you, so you might.
Okay. Well, hopefully he does. While he's coming, I'll show you a small application. Now up north, these guys produce a lot of heat. But up here, you would need them to be in some type of enclosure. It doesn't have to be a brick, nice building. It could be a small, there he comes. Yeah. We have them in a basement in a winery in Canada. And in the coldest part of the year, with no heat on the basement temperature stays around 87 degrees because of the heat these guys produce.
Any questions while we're waiting to get the PDF switched over? Anything?
You say it handles fog real well.
Very well, yeah.
Does that reduce your capacity?
No, well, then we're going to make you screen it, right? So the big clump's got to come out. But no. And again, the reason being is that the gill draws the fog through, right? Draws the fat, also grease to the dry side, so it's not suspended, and the bugs are having to try to, oil and water don't mix. Well, there's no water on the dry side, so they're getting gobbled up quite well. Okay, so just to give you an idea, and whatever your personal feelings about the environment are, it is a very big issue for a lot of people, a lot of governments, a lot of municipalities. Walmart recently started requiring their vendors to do something sustainable in order to keep selling their products at Walmart. Sabra Hummus, oh, you had it up, Sabra Hummus went to Walmart and said if we put a biogill system in to clean our water, which would reduce their carbon footprint by 683%, would you consider that sustainable? Walmart said absolutely. So I'm going to give you an example. We ran some numbers, and the project outline was an inlet BOD of 4,000, an outlet BOD of 300, with a flow rate of 12,000 gallons per day. And then we assumed 85 cents per kilowatt hour, which is actually higher than that now. A labor cost of $35 per hour, but if you're required to have a level 1 or level 2 operator, that's going to be closer to 50 an hour, which you would never have to have with us. And then a capital cost based on, we got information from our different distributors. I don't know how to scroll down with this thing. Let me see if it'll let me. I think I might have it. Let's see. Boy, this guy's hard. Can you scroll down one there with that mouse?
Is that a mouse there?
There's a mouse on that. There we go. Okay. Scroll to about right there. And I'm going to show you the breakdown, but we did a 20-year cost evaluation. And we compared ourselves to an MBR and an MBBR. And this scales, right? So in a larger system, the number's going to be much bigger. Over a 20-year period, the amount to own and operate an MBR and an MBR system is $2,371,000 cheaper to own and operate our system than an MBR, and about $500,000 cheaper than the MBBR. And actually, we're going to revise those numbers because we inflated our labor numbers and deflated their numbers. That's a significant amount of money. And scroll down for me again. But the bigger thing, keep scrolling, it's right here. 634% cheaper electrical usage. So if a carbon footprint is important to you, or important to your client, or if you have somebody coming in and they are all about, we got to be sustainable, we got to be green, we got to be eco-friendly, we're the only game in town for that, right? All right, this is for one unit, one ultra. Our energy cost is like our two ultras, rather. Our energy cost is about $300 a month. For the same flow, same strength water from an MBR, $1,900 a month. And for an MBBR, $1,700 a month. Now, when you scale that up, like the project like at Gen Foods, which is 12, right? So $1,600 a month is about $20,000 a year. Scale that up times 12, that's $240,000 a year lower light bill and smaller carbon footprint. And we even have a program called the BioGill Clean Water Partners. And if you use BioGill, you get all the certificates saying that you're an environmental friendly company and that you're in the clean water and the low carbon footprint. So it's important to a lot of people. And if it's important to your clients or your communities or internally to you, we're the way to go if you're for the low carbon footprint. And that's a lot of real money too. Saving Gen Foods $250,000 a year on their electric bill was a significant buying reason for them. So, any questions? Paul, and again, sorry I'm hoarse. It's your fault for being so cold up here. Any questions on this? No? Okay. Well, I'm going to give you two more quick things. I just forgot. So, our nano ceramic material, which actually China's space program is looking at, but it is incredibly tough. Yeah, I've tried to cut it before. You can't cut it. It's a 25, 30-year material. We give you a 2-year warranty with our units, but they're now made out of stainless steel and metal. That BioGill sheet's a 25, 30-year sheet. It's a 25-year solution. In any installation we do, we have a 100% performance guarantee. So if the inlet numbers you give us are accurate, if you tell us we have this much TSS, this much BOD, this is our flow rate, we will do a calculation. We'll say we guarantee this is what will come out. This will be your TSS, your COD, your BOD coming out. And if it's not, we come out, and as long as your inlet numbers haven't changed, we will come out at our cost and fix it until it does. However many times it takes, if it's 3 years down the line, whatever, we will come out and fix it and make the outlet number meet or exceed what we promised you at no cost to you. 100% performance guarantee. We're that confident in this product. And we have, like I said, we have them all over the world. It's working. It's a new technology, but it's tremendously good at removing BOD in a small footprint with almost no energy costs. Hunter, you want to add anything?
No, I was just going to say, to summarize, that was a low carbon footprint system, new system, very good with BOD, COD, low monthly cost. You don't need a licensed operator to maintain the system. Overall, good.
Well, Hunter actually has a project he's working on currently where a very large manufacturer's aeration pond has gone septic and isn't working anymore. And they're spending, we were told yesterday, $80,000 a month on electricity trying to blow oxygen to it. And we believe they're going to go with our solution. They want to. which would be we would literally pipe water out of their aeration pond through our units and then back into the aeration pond. We greatly reducing the BOD, and once we start doing that, they can start cutting off blowers and aerators, right? So we'll save the pond and massively reduce their electric bill. So, thank you for your time. Appreciate it.
Cool. Well, that's all I had put together for today. I don't know if Jason or if anybody else wanted to say anything or. Cool. Well, to all the people on YouTube, I appreciate you tuning in. Thank you to everybody here that took the time out and made it here safely. Have a good weekend and stay out of trouble.
If anybody wants data, literature, or anything like that, if anyone would like us to send technical data, literature, technical specs, just give Hunter your email, and we'll get that to you. And I'm sure the same goes for John too. Yeah.
Thank you, guys.